The paper of the day is The Adaptive Radix Tree, Artful Indexing for Main Memory Databases. It's a 2013 paper. In this paper, they developed the Adaptive Radix Tree, a fast, space-efficient, general-purpose indexing structure for main memory database systems. They proved that the space consumption per key is bounded to 52 bytes even for arbitrarily long keys, and show experimentally that the space consumption is much lower in practice, often as low as 8.1 bytes per key. They describe how common built-in data types can be stored in radix trees while retaining their order. They experimentally evaluate ART and other state-of-the-art main memory index structures, including the most efficient search tree proposals. By integrating ART into main memory database system Hyper and running the P26 benchmark, they prove its superior end-to-end performance in a real-life transaction processing application. Now, let's look at the evaluation that they did. They experimentally evaluate ART and compare its performance to alternative in-memory data structures, including comparison-based trees, hashing, and radix trees. The evaluation has two parts. First, they perform a number of micro-benchmarks implemented as standalone programs with all evaluated data structures. In the second part, they integrate some of the data structures into the main memory database system Hyper, which allows them to execute a more realistic workload. That is the standard OLTP benchmark P26. As contestants, they used a B+ tree optimized for main memory, like cache-sensitive B+ tree, or also called CSP. Then two read-only search structures optimized for modern x86 CPUs, that is KRE search tree, carry, or fast architecture sensitive tree, also called fast. Third, a radix tree, which is specifically generalized prefix tree, or GPT for short. Then fourth one, two textbook data structures, red-black tree and chained hash table using Murmur hash 64A for 64-bit platforms. Now let's look at the conclusion of the paper. They presented the adaptive radix tree, in short ART, a fast and space-efficient indexing structure for main memory database system. A high fan-out path compression and lazy expansion reduce the tree height and therefore lead to excellent performance. The worst-case space consumption, a common problem of radix tree, is limited by dynamically choosing compact internal data structures. They compare ART and other state-of-the-art main memory data structures. Their results show that ART is much faster than a red-black tree, a cache-sensitive B+ tree, and GPT and other radix tree proposals. Even the architecture-sensitive read-only search tree fast, which is specifically designed for modern CPUs, is slower than ART, even without taking updates into account. Of all the evaluated data structures, only a hash table was competitive, but hash tables are unordered and are therefore not suitable as general-purpose index structures. By integrating ART into main memory database system Hyper and executing the P26 benchmark, they demonstrated that it is superior alternative to conventional index structures for transactional workloads. Now let's give this paper a PS score. Overall, it's bumpy read with some super dense parts because of code and math, so it gets 7 out of 10 on readability. With 12 pages long, it scores 9 out of 10 on length. Reproducibility will be a bit challenging, so it gets 7 out of 10. Industry value and learning meter is decent, so it gets 8 out of 10 each. Overall PS score is 8 out of 10.